Hello everyone, my name is James Brown and I work here at PreciPoint. Today in this video, we'll show you another practical mode of the M8, the SlideScan mode. In our previous video, we have looked at the instant scan mode, and in case you missed it, it will be linked in the description below. But what is the difference between the instant scan and the SlideScan mode? Well, this mode performs as a scanner, digitizing samples in the highest quality and resolution to later observe them virtually. This will all be done by using the overview image that was produced when the M8 started.
I've already placed my samples on the stage, started micropoint, and waited until the hardware initializations have turned green. Let's select the SlideScan mode. It will then ask to place the slides again, but I already placed mine, so I'll click OK, and it will start with the overview image. As you can see, there is a pre-made scanning box. But of course, we can create a new one by pressing the plus button. Or by clicking on the desired scanning area while dragging the mouse to enlarge the window. In case you want to delete it, just press the minus button.
When it comes to the scanning configuration, there are a few focus choices available. So I hope you're ready for me to say focus a couple times.
The scan mode, single focus, is the fastest mode and is the best used for the scanning of smaller areas with little differences in the z-axis or flat samples. The samples are focused throughout the slide. The M8 runs an autofocus at one selected point, then scans the image without changing its Z position. Now, predictive focus is used for relatively even surface samples. The M8 uses different focus points to extract the best fitting focus plane for the scan. Then it drives along this abstract focus plane while scanning the slide. Next up is the intelligent focus, which is the default scanning mode and is usually the best option in balancing speed and quality. Just like in the predictive focus mode, the M8 uses focus points to estimate the best fitting focus plane to drive along with its Z position. Additionally, in this mode, it is necessary to specify your focus range between 10 and 400 micrometers, based on the slide topology. That way, the focus range determines how much the Z position should drive vertically in either direction for each tile scanned during the scan. As the Z position drives along the Z axis, the M8 finds the sharpest focus point in the specified range to select the best image for your digitized slide. Autofocus delivers exclusively focused images, and as you can imagine, it is suitable for slides with large differences in height. Again, we need to select the focus range in which the M8 or O8 runs its Z position along. However, it does not abstract a focus plane to run along, but rather focuses on each tile to start at the same determined point on the Z-axis. For very uneven objects on the whole slide, we have the focus fusion. Once again, when it comes to more complex modes, the focus range needs to be selected. However, in focus fusion mode, as the Z position drives along this range, it is not selecting the best image, but rather collecting the best pixels from each individual image among an entire stack of images. Then, the best pixels are merged into one sharp image, giving the best possible focus from the individual pixel level. There are also several other functions that may help you optimize your results. First up is the Sparse Scan, an optimization tool for all the focusing modes. With this feature, the M8 skips scanning images that do not contain tissues. This feature decreases the overall scan time. Another one is the high speed, which is an optimization for the intelligent focus. It only uses the autofocus feature in every other column and every other row of the scanning grid. When autofocus is not used, the images are acquired at an estimated Z position. A small side note, either Sparse Scan or high-speed scan can be selected, but not both. Here I have placed some different slides, and in case you want to see how to place new ones, we'll link the video on the information box and down in the description. Okay, so by default, the Performing Illumination Correction is selected, which homogenizes the background to eliminate the uneven tiling patterns. To do this, the M8 identifies a white space, or an area without sample on the entire slide. Then this white space is replicated throughout the whole slide to correctly light up the sample with the optimal illumination. The white space is determined using our algorithm and can also be adjusted manually by right-clicking the scanning area. Click on the Edit Illumination Correction and manually move the yellow square where you feel like the illumination is best. That looks good to me, so I will go ahead and start the scanning process with this play button, and I'll select the folder where I want to store my scan. The live image box is pretty self-explanatory. It's where you see exactly what the M8 is scanning. Finally, another default feature is the Detect Focus plane. The M8 will use a focus point to detect the approximate location of the sample before starting the scan. And of course, once again, this can also be generated through our algorithm or set manually by right-clicking the designated scanning area. Click on the Edit Focus Points and manually move the red or blue points. The blue point is the very first position where the M8 will perform a pre-large range autofocus to first coarsely find the sample and then conduct a fine search at the red points. We can add focus points by double-clicking, and if we want to remove them, all we have to do is double-click on them again. So let's start the scanning process. If we deactivate the Detect Focus plane in the Predictive and Intelligent Focus, it skips this blue spot, leading to only focus on the red spots. In the Single Focus, Autofocus, and Focus Fusion, it isn't pre-focusing at all. In the information element inside the info bar, the progress bar will be yellowish if the scan is active. Once the scan is complete, the progress bar will turn green. Naming the scans is a very simple process. First, select the scan that you want to name and click on the specimen ID/barcode, and just type in the name of the scan. Let's now create multiple scanning areas and rename them. And let's start the scanning process. As you can see, our info bar is yellowish, so that means our scan 1 is now active. You can abort mission for single scans by clicking this pause button for each scan, and reset the scanning with this return button. Let's initiate the process again. But now if we want to abort mission for all our scans, we can go ahead and press this pause button and confirm on the next window. Now all our scans have a blue bar. Once we reset everything again, we can do the same adjustments and restart the process. When the scan is ready to go, you can open it using the viewer. There are two ways to do so. Either open it with the viewer directly, or we can open the folder and open it from there. In case you want to see how the scans look in the ViewPoint, we will link the software in the description below on our page where you can download the ViewPoint for free and some sample slides as well. But we will also do a tutorial on that if you'd like to wait.
And that's all for this tutorial. We would like to read your comments and any questions you have. Also, if you're an M8 user, what additional features could there be? As always, we'll have everything linked in the description and where to find us. Like and subscribe for more. Thank you for watching. Till next time.